All right. Hopefully, I'm doing this right. Okay. Ooh, you know what I'm gonna do? The
Mm.
the thing that I'm gonna be working on, I'm gonna just put it in the Discord
Oh, bet.
under Calc AB, obviously. Add, upload file. Um. Okay, so the one I have pulled up
Mm-hmm.
is FTC Part One or Part Two. I don't
Uh,
know which one they have it as, but the 6.4 packet. Where's
yeah,
my phone at? I'm trying to get my phone so I can read the chat. Hold on, where's my phone? All right. Uh, Hold on. Let me grab my phone real quick. Come get the phone. Hey. Okay. We're back. All right. Um, Let me know. Let me know when you're ready so I can start.
I'm ready.
Okay. I guess we can just start with number one, right?
Um, yeah.
All right. So it says. Remember FTC. Let's recap first before we just dive right in. Uh, so basically, all right. Let's read. Let me read what this says real quick. Last lesson we learned about the definite integral. Okay, so that symbol means. Let me get my tablet here. You see what I'm reading at the very top?
Yeah.
So this represents the area under the curve from A to B. We already know that.
Mm.
All right. So let's say we know where the interval starts at A, but we do not know where it stops. That would give us an integral. Actually, let me make this skinnier. From what to what is my question to you. If we know where the integral starts, but we don't know where it stops, what would I put instead of B?
X.
X. Okay. And that is the integral under f of x. I mean, we can call it f of t. So we don't,
Right.
since we already used x.
Mm.
Okay. Oh, I guess that's what they want us to write right here. Capital F of x. That's going to be the integral from a to x of lowercase f of t dt.
Yeah.
Okay. Is it all coming back? Am
Yeah.
I? Let me make sure I'm on stream. Hold up. All right, I am. Bet. Bet somebody's in here. Shout out to whoever you are. Okay, so let's keep going. Let capital F of x be the integral from 0 to x. Use the graph of f. It's important too because you know how sometimes they'll give you the graph of f or they'll give you the graph of like f prime, you know what I'm saying?
Yeah.
So you got to pay attention to what they give you. So this is the graph of lowercase f from 0 to 5. So complete the table. All right, so they give us x. They want us to fill in capital F of x,
Uh,
which remember they defined it up here. They said that capital F of x was the area from 0 to whatever x is. And so for our first entry in the table, they're saying what is capital F of x whenever x is 0?
one.
Not even, because when x is 0,
All right. It's
that's the
zero
integral
zero.
from 0 to 0. So
That's
the
zero.
area is just 0. Yeah. So now I have to ask, just for my own learning and teaching, what made you say 1?
I just looked at the graph.
Okay. And but where x is 0, y is 3 on the graph.
Yeah, I thought that was one.
Oh, okay, okay, okay. All right. So When x is 1, that is the area under this curve from 0 to 1. So on the graph, we're looking in between these red lines. So we just have to find all of this area. That you should be able to do just looking at it.
It's like a rectangle, right?
Well, not just a rectangle. You could think of it
Yeah,
like,
like a triangle and a rectangle.
yeah, you could think of this like a rectangle, which would have area what?
One. Wait. Yeah, two.
Yeah. And then you see how the triangle is just a square cut in half?
Yeah, so it's 0.5.
Yeah. So the
So
overall area would be 2.5.
Mm-hmm.
There's an answer key to this. This is on
Mhm.
Flip Math.
Ah,
There's an answer key. I'm gonna look at it. Maybe not right now, but like once we fill out some. All right, so you see the concept is the same. So when x is 2, it's just the area from 0 to 2. You know what I'm saying?
yeah.
So you could think of it like a trapezoid, or you could really split it up however you want. But I'm thinking the area is 4 just from looking at it.
Yeah.
I see 1, 2, 3. This right here is 0.5, and this right here is 0.5.
Yeah.
So, but do we have to do all of them, or do you kind of get the idea?
Yeah, I get the idea.
All right. Now the only thing is, remember what's important down here.
You gotta subtract.
Yeah, you got to subtract. That's like, because you know how it's always easiest to think of this in terms of like speed and time,
Mm-hmm.
or distance and time, or whatever your y value is. If it's negative, that's like, it's I don't know what to say. It's literally under the x-axis, so its y values are negative. It's like, yeah, you just got to make sure to look out for it. This is called an area. I don't know what they want us to say for that. What could that be? The fact that it says "an" lets you know that the next word starts with a vowel, right?
Yeah.
What else could it be other than an area? Wait, no, this is called I don't know. Accumulation?
Should be something like that, right?
Accumulation could be it, right? Because you're accumulating more area. I don't know. I'm going to look at the answer key. They say, wait, is this the right one? Or do they not have all the answers? Huh. I guess they don't have all the answers. Or maybe it's in the video.
Graph. We can
Oh,
label
yeah, it's in
this
the
one
video.
little f of t. That's what this is. What does that equal? One square, and I get one block accumulation. It's
All
now
right, you see
5,
that's what
1,
we were
and
getting?
2.5 with, getting smaller depending on the graph below the x-axis. But that's what it is.
Holler at your boy. Do you see what it says?
Nah. I didn't show.
Oh, I didn't share my what you call it? Hold on, let me share the right screen. Basically, hold on, I'll just show you. All right, can you see it now?
Yeah.
Yeah.
Accumulation. Yes, sir.
Okay, we were right. Okay, so anyways, moving on. Fundamental theorem of calculus. If a is a constant and f is a continuous function, do you remember what is the derivative of an integral?
It's just the function itself, right?
It's just the function itself. So really this is just f of x. But it's not gonna be that easy. It's not gonna always be that easy. So I guess
F of B minus F of A sometimes.
yeah, and we can even go as far as to do that. So let's just go ahead and stay on that note, since we're, since it's fresh on our minds. So
Mhm.
look, remember how you said f of b minus f of a, right?
Yeah.
But in this case, what is it instead of a and b?
X and A.
Yeah, well, a and x instead of a and
Yeah.
b. But look
Mhm.
though, you're still that f of b minus f of a is just the integral part. You're still
Right.
taking the derivative. So tell me what you think about this. Now we can go like instead of f of b, we'll say f of x, right?
Mhm.
Minus what? According to what we
Uh,
just said.
F of A.
Yeah. Yeah. Okay, but it's the derivative of that. And do you remember how when we take a derivative of like the difference of two functions, you can take the derivative term by term? I feel like
Yeah.
I say that all the time in class, right? Term by term.
Uh-huh.
Yeah, I feel like uh, we know what that means. So let's do it term by term. So the derivative of the first term looks like this, right? Now, I'm not even going to write it, but remember what A is? I think they say it up here. Oh, it says it right here. A is a what?
Constant.
A constant. F evaluated at some constant, that's like saying F of 3. You know what I'm saying? It's going to equal some number.
Right.
I don't even know what number to put. I'm just making an example. But what I'm trying to say is you're taking the derivative of a number, which is
Mhm.
what?
Um, Constant.
Well, what is the derivative of a constant?
Oh,
Like the derivative of 2, for example.
0.
0. So no matter what a is, it's still a constant. And
Right.
so the derivative of a constant is 0. So you're really minusing 0, but we don't need to write minus 0, of course.
That's basically this. D dx f of x. Like the
Yeah.
derivative of f of x. Yeah.
Well, it's the derivative of the integral.
Right.
So do they call it capital F? They don't. Um, this is actually going to be capital F of X. I think that's what they do in the next part. Like, you know how there's two parts?
Right.
I mistakenly wrote lowercase. That whole
Uh,
time that should have been in uppercase. But I feel like whether it's lower or uppercase F, evaluated at A is still going to be a constant.
mhm.
And the derivative of a constant is still 0.
Yeah.
Okay, let's just keep going. Derivatives and integrals are anyone?
Um, like, ooh, they cancel out each other.
Yeah,
What's
that's
the
what it
word for
says
that?
here. There's a word for that.
Uh,
Do you want me to just tell you?
yeah.
This is what I'm thinking.
Versus.
That's what I'm thinking. They cancel each other out just like multiplication and division. Um, so here's where I was writing that capital F. So capital F is considered you can say antiderivative or integral. But I'm willing to bet that antiderivative goes right there.
Yeah,
But let
maybe
me
just
read
take
that
that.
out so that makes sense. So the graph of F is the derivative of capital F. And so that makes capital F the antiderivative. It's like going backwards, basically.
Uh,
Yeah. Tranquil Sea of Math says hello. What's good, Tranquil Sea of Math? Okay. Now, here's where it can get kind of tricky. Now, you see how the bounds aren't from a to x?
A to like a function.
Yeah, a to a function. So it's going to be the derivative still, but remember how we said the integral of lowercase f was capital F?
Yeah.
Of something minus, in this case, capital F of A.
hmm
And remember how last time we said that that capital F of A evaluated to some number, like any
Yeah.
constant, and the derivative of a constant will be 0.
Right.
But what do we put in the first parentheses, though?
F of g of x.
Yeah, F of G of X.
How did that
Now,
work though?
because whenever it's just like A and B, except where this was usually like a B. Remember how it was F of B minus F of A?
Yeah.
But this time it's G of X. It's just
Uh,
whatever the upper bound is.
hmm
But the whole point is you're taking the derivative of capital F, which is a function, evaluated at G of X, which is another function. What does that sound like? We learned that in what? No. September, October?
Hinru.
Chain rule. So, what does chain rule say?
That's like f like to the power of n. Is it n? Like you
Well,
multiply the function times the derivative of the inside.
yeah, and you keep the inside the same
Yeah.
times the derivative of the inside. Or I guess capital F, we'll keep it consistent. Capital F or capital F prime, which is lowercase f. That's what I meant to say. Which is going to
Uh,
end up being this.
yeah.
Remember how it's just the function itself? You plug in the inner and then you times by the derivative of that upper bound.
Alright, so
Same.
if there's like a power on the integral, so like a to like let's say x squared, would that
hmm
be a chain rule?
Yeah, anytime it's a function.
Uh,
Yeah. And low key, if we scroll back up, if we treat x like a function and do the same thing, what's the derivative of x?
1.
1. So this technically still is true.
Oh. Wait, so if it's like x squared, would that be like 2x times 1? Or would that be like x squared times 2x?
Well, it wouldn't be x squared times 2x. You'd have to plug in x squared in for t.
That'd be like 2x times 2, right?
Well, it just depends on what this function is.
Oh.
So I guess I can make up an example.
Alright, yeah.
So let's do the derivative with respect to x of the integral from 0 to, I think you were talking about x squared of, I don't know, sine of t dt equals what? That's a
Is there?
pretty, I think that's a pretty decent question.
Yeah.
So that would just be the derivative of an integral is just the function itself. But we got to do the f of b minus f of a stuff.
Right.
And it's the function itself evaluated at x squared. But because it's the derivative, we got to multiply by
2x.
2x minus 0 technically. But if this was like a multiple choice, it probably would have looked like this.
So is there like any situation where you like take the value of the derivative of the bottom, like f of a?
Maybe if it's looking like this, where the bottom part is a function.
That's like the only case you take the value at the bottom.
Well, you take it all the time. It's just that when you multiply, like when you plug in 0,
Mm-hmm.
you get a value. Like sine of 0 is a value, and you're
Right.
taking the derivative of a value, which is 0. So you're minusing 0 every time. Yeah. So here are some examples. I'll do one, and then you do one.
I bet.
Okay, so in all of these, they want us to find the derivative of capital F of x.
Mm-hmm.
And so if you look, the right side of it is an integral. And so the derivative of an integral, as we know, is just the function itself.
Mm-hmm.
Evaluated at the upper bound minus the lower bound. So this is just going to be 3x squared plus 4x. And that's it. Technically times 1 minus 0 if you want to get technical.
Wait, ought to be times 1.
So you know how like we replace t with x,
Uh-huh.
and x, you consider x like your inside function.
Yeah.
And so you would need to multiply by the derivative of that inside. And the derivative of x is just 1.
Mm-hmm.
So
Is that like 4x? Would I multiply the whole thing by 4?
no, you just replace t with x. Yeah.
Alright, so I did number 2, right?
Yeah. Go for it.
Alright. Oof. This should be like sine x cubed times 3x squared
Yep.
minus sine pi over 2.
Well, it's the derivative of that, which is just 0.
Wait, it'd be 0?
Yeah, because remember how we're trying to find f prime?
Yeah.
And so we're trying to find the derivative of this integral.
Mm-hmm.
Maybe I'll try to write it out like this. It's the derivative with respect to x of the integral from pi over 2, which is a constant, to x cubed of sine of t dt. And so that's literally like saying the derivative with respect to x of, now the thing is, I guess we could do this. We could do this like the real way, because we know the integral of sine. We know something that if you take the derivative of it, you get sine. And that
Yeah.
is negative cosine.
Wait, I thought it was just normal cosine.
Well, the derivative of cosine would be negative sine.
Yeah.
And we're trying to get positive sine.
Oh.
So we're going to go like this. And remember how we do like the f of b? So like this negative cosine is like our capital F.
Mm-hmm.
Or our lowercase f, I guess, in this case, based on what they called it. But the f of b minus f of a is what I'm trying to say. And you know how in this case our b is like our x cubed?
Yeah.
And then we're going to go minus a negative cosine, which is really plus cosine of pi over 2.
Wait,
That's like
why
our
we
f
go
of a.
plus cosine again?
Well, it's minus negative cosine.
So minus negative cosine gives us like a positive sign, right?
Well, I'll write it out the long way. So you know how it's like f of b minus f of a,
Yeah.
and our f is negative
Oh.
cosine. So we're like
Yeah.
minusing a negative cosine. And And so, but remember, we're taking the derivative of that.
Mhm.
And so cosine of pi over 2, that should just be 0. And the derivative of 0 is just 0.
Yeah.
So, and then when we do the first term, the derivative of negative cosine is just sine. And then we keep our inside, which is x cubed. But because x cubed is a function, we're going to have to use chain rule and multiply by the derivative of that.
3x squared.
Yeah. And that's what we got above.
Mm.
It can get tricky, but as long as you don't overcomplicate it,
Yeah.
which it's hard not to, I know.
Yeah.
But the basics is you're taking the derivative of a function inside of a function. And so you got to use chain rule. So for like number 3, capital F prime of x, it would just be equal to h of t. But
it's
instead
just
of
like
t,
4.
we're going to put
4.
4x.
Yeah.
And then times by the derivative of 4x, which is just 4, minus 0. So you can put 4 times h of 4.
Okay, so like every time you're trying to find like a f prime of x, you like cancel out the derivative and then multiply times the times like g prime of x, right?
Yeah,
But like if it's on top,
right. Minus
I
uh the derivative of h of 1,
yeah,
which is just
so that's
0.
a 0. Yeah.
Yeah. Okay. What do you want to do now?
Let's see. I'm down for some more practice.
Hey, you know I'm always down.
Sir.
Well, number 4, if you're taking capital F prime of x, it's just the function itself. So 5t, but we're replacing t with x.
So 5x times 1.
Minus.
So basically plus 1.
Well, we're gonna do the same thing, but now we're gonna plug in a negative x in place of t.
Oh.
And then we gotta multiply by the derivative of negative x, which is negative 1.
Right.
So this first term becomes 5x. Now we got minus 5 times negative x times negative 1. So that's a positive x. That's what I'm getting. I think 5x minus a positive 5x.
So that's 0.
I want to check that one. That one looks weird. From negative x to x. Actually, no, that does make sense.
Yeah, it adds up.
I think. Because that would be, what, 1/5? I don't know. Let's check. I want to check before I do something wrong on stream. Where is it at? Oh, wait. I forgot that on. Oh, wait. No. It's on the video. Maybe. I don't know how much of the video. Oh, wait. No. Here go the answers right here. Was it 0? Which one was it? Did we not do that one? Number 4. I don't
That's
see
not
it.
the same one. I think it's a different one.
Well, it's 6.4 accumulation functions.
I think
6.4
it's like,
accumulation functions.
I think it's the one below.
Is it in the video?
antiderivative.
how much
And then if we
you did.
wanted, we could put of what you just plugged. And now we simplify. This
All right,
becomes
here it goes right
5x.
here.
A minus and a minus is positive, but then another minus. And so negative, negative, negative. That's going to give you a negative 5x.
Yeah.
And then that simplifies down
Okay, bet.
to 0. Okay, let's try this
All
one.
of that strife to find that
Uh,
problem. But at least we got it right, though. All right, number 5 is all yours. No pressure.
Right. T squared minus T 3x. So it's 3x squared minus 3x
Wait, let me write
time.
Write what you're writing.
So 3x squared minus 3x times 3 minus 2x squared minus 2x times 2. But we can use a chain rule here. Like, is it a double chain rule?
No.
Alright, let's just exponent then. So that's like 6x minus 3x times 3. Right?
Wait, hold on. Let me catch up to you. I'm just plugging stuff in for right now. Okay. First of all, let's make sure we're good here. I replaced t with 3x
Yeah.
in the first term, and then multiply by the derivative of 3x, which is 3, minus, and then I replaced t with 2x multiplied by 2. Is that what you did?
Yeah.
Okay. So now, in this bracket, this first bracket, that's going to give me a 9x squared. I'm going to
Yeah.
put the 3 out front. So that's going to be a 9x squared minus 3x
Uh-huh.
minus, and then I'm going to put the 2
4x
out front.
minus 2x.
4x squared minus 2x.
Wouldn't it just be like 4x? Because once you distribute it, it just like cancel out.
Well, we're replacing t with 2x, and so that whole 2x is all being squared. Like you see out here, I put a 2x instead of a t.
Yeah.
And so when I square that 2x, the 2 becomes a 4 and the x becomes an x squared.
Oh, like a whole thing square.
Yeah.
Alright.
All right, so now we distribute 3 times 9. I think that's what, 27?
X squared.
X squared minus 9x minus 8x squared
Plus 4x.
plus 4x. Combine like terms was 27 minus 8. What's that, 19?
19. Yeah.
X squared plus minus
minus 5x.
5x. That was an algebra problem right there. I wouldn't be
Yeah.
surprised if you like saw that on like a I don't know, like a retest or something. That one was a good one. I don't know. I'm just thinking out loud. Let's check it. Is it on the video?
This
should be.
last
Probably.
one. And 5x. There we go. That
Is that what we got? 19x squared minus 5x?
Yeah.
Okay. All right, let's do some more. This is what separates the good from the great, Dev.
Yeah.
All the mother folks aren't putting in the work like you're putting in the work. They're not with you shooting in the gym, bro. They're playing Hogwarts right now.
Oh, you play that game?
No. I just know it's gotten people, it's knocked people off of their grind. That's all I know. All right. I'm gonna be honest with you. I'm not finna sit here and do all 12 of these. I feel like these will be good for you to practice on your own, since
How
we
about we
kind of
go
got
to
the
like
gist
the
of it.
like the hard ones?
Uh,
Like any you think are hard. I'm gonna give it a try.
I mean, mm, anyone 10, 11, or 12.
11 or
Honestly, I mean, yeah.
mm. All right. I'm gonna give 11 a try right now.
All right. Well, nah, do 10, do 10, do 10.
10.
Yeah, do
All right.
10.
All right. So 10 of X. Yeah. So it's it's just basically f of b because f of a f of a is 0. So
We're gonna enter. I'm gonna have a stream setting, not a setting, but something I call test mode, where we're gonna act like it's just a test, and you know how I don't be helping y'all. So you gotta come up with what you can.
I bet.
If this
So
was a
10x
test, what are you gonna do?
10x squared times secant square x.
Hey, somebody might have been on their flashcards. I don't know.
It's alright, so it's 10x squared times secant square x, right? So like
It's test mode. You gotta
that's
you gotta come at me with your final answer
oh
and lock
alright,
it in.
alright. Mm,
Y'all be like, blink twice if it's the right answer. I'm like, no. Not blinking at all. After this, we can do like, hold on, let me see. I mean, 19 might be good. 20 might be good.
Alright, so I think final answer is secant square x times 10x squared.
All right. Wait. Let me write it down. Hold on. Let me say what you said again.
Alright, secant square x times 10 square x.
Like
It's a 10x
this.
squared, 10x squared. Let me see.
Like
Yeah,
that.
yeah.
All right. Let's see. Mm. This is what, 11
This was
or 10. Look what they got.
10.
That's basically it. Secant squared x
Yeah,
times, but you know, tangent x squared is the same thing as tan squared x.
yeah.
It's weird, but okay.
So I get the credit for that, right?
What you mean?
Like if it was on a real test, I get the credit for that, right?
Oh, yeah. I thought you meant
But
like, does this count? I was like, nah,
oh
homie.
no.
We're just practicing. Okay.
Yeah.
I mean, I can see there being one like 18 on the retest just because there was one exactly, literally, like I think word for word,
But
exactly like
this
this.
is easy. You just plug in -4, yeah?
Yeah. Wait, if it's easy, we shouldn't be saying yeah. You
What do
should
you
say it
mean?
with some confidence. Make a declaration, a
Yeah.
statement.
This one's really easy.
There we go, with a period at the end, not a question mark.
Yeah.
Okay, because the g of x is the derivative of an integral, which is just the function itself,
Yeah.
which is this.
I haven't memorized the answer to this one on the test. It's like 5.
I don't even know. I didn't even pull it from this exact question, but I
Actually,
remember.
this one's really similar.
Yeah, yeah, because that's what 16 plus 9, which is 25. Is 5 an answer choice? It is.
Yeah.
All right, number 19. The graph of a function f on the closed interval is shown above. It's 0 to 6. H of x is right there. Find h
Find H.
prime of 3.
Oh, this one easy too. It's just the value. It's f of b minus f of a. It's like 0 to 3, so f of 3. So that's 0 minus um 2 to negative 2.
A?
Yeah.
Okay. Let me
This one on
see.
the test too.
All right, let me see. So they give us h and they want us to find h prime of 3. Whenever they do this, I don't know if this is smart or not. I always just find h prime of x first, and then I'll plug in 3.
Oh.
So what is h prime of x? It's just the
1.
derivative of this.
Yeah.
Oops, I meant to circle the derivative of this. And that is the derivative of an integral, which is just the function itself, evaluated at the upper bound. So that is h prime of x. And if they want h prime of 3, that is the same thing as saying f of 3. And they give us the graph of f. So f of 3 is 0.
Oh, I thought it was like 0 to 3. Like,
Yeah, it is, but it's the derivative of that though. That's where people don't be careful.
oh.
Had they said find h of 3, that
Mhm.
would have been something a little bit different. That would have
If
still
it's
been
an
a
H of
positive.
3,
I mean, we
that
could
would be the
find it.
area, right?
Yeah,
Yeah,
from
that would
0
be
to
the
3.
area.
That would
Yeah.
not have been negative 2 either.
Yeah.
That
On
would
the
have
test, it
been
was like,
what? 4 plus what? All of this right here is 4. And then this
the
is like
question on the
1.
test, it was like the graph of a piecewise function is like shown, and the value
Mhm.
like integral of 3 to 8 for like f prime
Yep.
of x.
Me and my homeboy did that one on stream just the other day.
Oh, really?
It's on my page now.
Uh,
You should watch it.
alright.
But yeah, let's try 20.
Ooh.
Okay, so they give us f of x is 1 minus cosine of x over x. I feel like that's a flashcard one, no?
Yeah,
Like
0.
the limit as x approaches 0.
Yeah.
All right, for x is greater than 0 and the vertical line x equals b. If b increases at a rate of pi over 2 units per second, how fast is the area of region A increasing when B is... Ooh, this is a good question.
Have you done this
I don't know if
before?
I've done one like this before, huh?
Have you done this before?
I haven't. I don't think.
I don't think we've done this yet. I'm gonna try it though.
Facts. Okay. This is interesting. Okay. So, all right. So let's just look at the graph and make an integral based off of that. And you see how it says, I'm going to highlight some important stuff. For x is greater than 0,
Mhm.
and the vertical line x is b. X equals b. So this area, which changes at a function of b, or do I want to say a of x? Well, the area changes based on b, so I'm going to say a of b.
Actually,
Can
it's
we say
based
the
x is equal to
integral
b, right? Yeah.
from 0 to b of f of x
Mhm.
dx? Okay. And they're also telling us, it looks like they're telling us like db dt
db dt. Oh,
is
that's
pi over
basically
2.
yeah.
And so they want to know how fast the area is increasing.
Oh, why'd it be db dt again?
That's just the rate at which b is changing
Oh,
per as a function of time, because it says units per second. So they want to find dA dt, which we can write as a prime of t when b is equal to pi over 3. This looks like a bonus question. All right. So we want to find the derivative of this integral, which is the function itself. Do you see how our area function is an integral from 0 to b?
Yeah.
We're trying to find the derivative of that integral. So I'm thinking that's just going to be the function itself evaluated at b minus evaluated at 0. The only thing is, if b is increasing at a rate of pi over 2 units per second, I want to say, No. I'm going to write it and then I'm going to explain it. Okay. So b is like a variable. It's like a variable vertical line. You know what I mean?
Yeah.
According to the graph. And you know how we have to use the chain rule whenever we do f of b minus f of a?
Yeah.
And then we do the derivative of that b function. It tells us the derivative of that b function right here. Because
So
it's the rate. And remember,
right.
we said a rate of change is like a derivative. So can you see why I multiplied f of b times pi over 2?
Yeah.
Okay, and then minus f of 0 times the derivative of 0, which is just 0. But I think I can evaluate f of b because I have f of x.
Yeah.
And I know a b value.
Isn't f of x basically 0?
F of x is this right here. We're trying to evaluate f of b times pi over 2 minus f of 0 whenever b is equal to pi over 3. So that's going to be equal to 1 minus cosine of pi over 3 all over pi over 3 times pi over 2 minus, now I'm going to do f of 0. So that's going to be 1 minus cosine of 0. Hopefully I'm doing this right. Over 0 is kind of sketchy.
Yeah. That's just undefined, like the second function.
I don't know what that means in terms of subtracting an undefined number, though.
Yeah.
Cosine of pi over 3. That's what, 1/2? 1 minus 1/2, which is just 1/2. Divided by pi over 3, I'm going to keep change flip. And then times pi over 2 minus, I don't even know what that is. But, because it's not 0, though. That's the only thing about it. So that makes this whole thing undefined. I don't know how to do this problem. But if I were to have to guess, I would just say these pi's will cancel out. I'd have
3
a 3
pi
on.
over 4 pi.
Yeah, but the pi's would cancel.
All right, so 3 over 4.
But I highly doubt that's it, just because I'm minusing an undefined number. I got to figure out how to do this question. Once I figure out how to do this, bro, this whole time I had been considering or debating what type of TikTok tutorial to make. I think I found my one, bro. This one is
Which one?
kind of weird. What's the answer? I think they have it worked out too.
Oh,
Oh,
it is.
let's go. I got it right. Okay, so what did they do? What the heck? So they said
Looks so
DA,
organized.
huh?
Looks so organized. Like,
I know. So I see what they did. 1 minus cosine of B over B. And then, okay, so they did exactly what I did. 1 minus, oh, so they just said, so they just did it like this, I think. Look, remember how we're doing it, f of a function minus f of 0? And we don't even like, f of 0 is some constant. And so the derivative of a constant is just 0 anyway. So
yeah.
it's like, but that's weird though.
This one not that hard if you like understand what you're doing. Like,
Yeah. The
you just
wording
gotta
is
under.
weird. The wording is the hard part. If B increases at a
Yeah.
rate. Yeah,
Hmm.
so the wording, this is a good problem. I know the kids would lose their mind if I put this on a retest, but I feel like this would be like something like this would be a good extra credit problem.
That would be a good extra credit problem.
hmm I'm down to start putting extra credit so I can give y'all even more chances to get y'all's grades. You
Sure.
know, yeah.
Yeah.
But
Um.
of course, the extra credit, it's got to be a doozy. I'm glad I got that one right. That one was kind of low key hard a little bit.
Yeah.
Bet. All right, now let's do some of the other FTC
Hmm.
6.7.
Uh.
Okay.
I, I had a question, Mr. Ullman. So like,
Yes.
it's about the differentiable function like on a graph.
Mm-hmm.
Like, remember the one we did? Like, the let f be a twice differentiable function.
On the test.
Yeah, like decreasing concave up and
Oh yeah,
positive.
yeah, yeah.
Yeah, could you
Oh
explain
yeah,
that?
yeah. Where was that? I think I remember. Actually, I think it was on this one. Let me find it real quick. I'm pretty sure it was on here. I did a good problem yesterday. I don't remember where I got it, but I can find it again. It was a good one. Mm, this is hurting my eyes. Okay, here it is. Is this the one you were talking about?
Yes.
All right. So, well, let's read it. F is a twice differentiable function defined by the differentiable function g, such that all of that stuff at the beginning is just jargon, bruh.
Mhm.
I hate when questions are so wordy. Like, just get to it,
Oh God.
right? This, shoot. I didn't mean to. I forget when you hit undo,
Mhm.
it scrolls. This is hurting my eyes. Wait. I seen an equation of a tangent line. Ooh, that's a good one.
Where's the equation of rotation line?
Y minus y1 equals mx minus x1.
Oh yeah, there's a point slope.
Point
Right, and it's
slope.
like,
Yes, sir. Okay, back to where we were. This is all you need to know.
mhm.
Well, not all you need to know, but it is also known that g of x is always concave up. Okay, let's just start there. For g or for any function in general to be concave up, what does that tell you about the second derivative?
Second derivative is increasing.
Not even.
It is.
It means the second derivative is positive.
Yeah.
The second derivative is positive. Hold on 1 second. Hello?
Yeah, what you doing?
I'm streaming.
Oh, well, talk to you later.
Okay.
I was wondering if you was alright. Alright.
Yeah, I'm fine. Thank you. It's positive. Okay, that's what I was trying to say. The second derivative is positive. Remember,
Right.
second derivative tells us concavity.
Mhm.
If it's negative, concave down. If
Yeah.
G double prime is positive, then it's concave up. So that's a fact. We have another fact. What else does it tell us?
It's
G of x
decreasing.
is decreasing. That we can get information from the first derivative. Do you remember when we said if the first derivative was negative, then that means that our function is decreasing.
Yeah.
Okay. And lastly, it tells us that G of x is positive.
All real numbers.
That just means exactly what it says. G of x
G of x
is
self-
positive.
Yeah.
So we know that G of x is greater than 0. Which of the following could be false? Which of the following could be false? If only one of them, this is kind of like a logic question too, because if only one of them could be false,
The
then
rest are
3 of
true.
them could not be false,
Yeah.
meaning they have to be true.
Yeah.
So which 3 are true is what I'm asking myself. And I'm noticing that all 4 answer choices involve f of x. And we
Yeah,
know
so they
stuff
weren't.
about f of x. We know it's equal to the integral of g of x.
Right.
Okay, well, let's see. G of x, let's just start from the bottom.
Mm-hmm.
G of x. How do I obtain g of x from this right side? What can I do to the right side of this equation to obtain g of x, which is just the function itself?
Prime it.
Yes. And if I prime the right, that means I got to prime the left.
Right.
So what I'm trying to say is
F prime f is equal to g of x.
exactly. And it tells us that g of x is positive.
Yeah.
So that means f prime of x must also be positive.
Mm-hmm.
And what does it mean if f... Whoa, we have people in the chat.
Oh, dang.
I don't be paying attention. Who is this? I don't know who that... Oh. Got you. Okay. F prime of x is positive
Yeah.
because g of x is positive.
Mm-hmm.
What does it mean? What can that tell us about f if f of x is positive?
That means wait, is it increasing?
Yes.
Yeah.
F of x is increasing if its derivative is positive.
Mm-hmm.
Is that an answer choice?
Yes.
Okay, remember, that one is true.
Mm-hmm.
And we're trying to figure out the one that could not be true. So,
Right.
can't be B. But it also says that G prime is negative. Do you see how I can get that if I take the derivative twice on the left side?
Yeah.
Or
Wait.
even if I get from G to G prime,
Oh, yeah.
I'll go
It's
from
double
F prime to F double prime. And if G prime is negative, then that means F double prime must be negative. If F double prime is negative, what does that tell us about F?
That means F is concave up.
It's negative, so it's
Oh wait. Oh shoot. So
concave down.
it's concave down.
So it can't be A.
Mm-hmm.
C and D are the harder ones to like figure out. Um, so and I love this is like the coolest part about math, bro. I swear. So look at answer choice D. It
Mhm.
says that f of x equals 0 for some x. Now look,
Y-
I knew that f of x could be equal to 0 if this x right here was a -2, because that would be the
Uh-huh.
integral from -2 to -2.
Yeah.
And x -2 is certainly a real number. So I
Uh-huh.
know that D has to be true. But somebody else said that um, if G is concave up and positive, then
Mhm.
that means if it starts at -2 and
Oh
it's
yeah.
positive, then that means at some point it has to cross 0.
Right.
So that was kind of another way you can think of it. And because process of elimination, you can pick C.
Right.
That was the hardest one on the test, in my opinion.
It was it's definitely one of the hardest.
Yeah, that one
I was
was.
struggling with the other graph too.
Was that not even the one you were talking about?
Nah, this was.
Oh, okay, I was about to say.
I was struggling with the other one too, the differentiable function, like f is shown above. Like they give h of x.
Oh, and you had to rank them.
Yeah, that's like the same thing, right?
Um, I don't know. Was it one where it was like h prime of 6, h of 6, and h double
Yeah,
prime of
yeah, yeah.
6?
Uh-huh.
Okay.
Yeah.
Well, I'll just try to draw that one. Um, where can I draw it at? I'll just sketch it right here. It was just like this, and it said something like,
Uh-huh.
and then this was 6,
Yeah.
and this was f,
hmm
and they told us that h of x was the integral from 0 to x of
Yeah.
f of, I guess, t.
dt.
Oops. All right, I'm gonna change this to a t. So yeah, we just wanted to find h of 6,
Yeah.
h prime of 6, and h double prime of 6.
Yeah.
Okay, so h of 6 just means I take h of x and replace
hmm
x with 6. And so
H of six.
do you see how that'll be the integral from 0 to 6?
Like h of 6.
Yeah, so like I'll write it out, but it's the same thing as h of x, except wherever there's an x, I'm going to put a 6 instead.
Oh.
So it's going to be, instead of the integral from 0 to x, it's going to be the integral from 0 to 6
Right.
of f of t dt, which is literally just by definition the area underneath that curve, or the between the curve and the x-axis, I should say. And
Uh,
can you see that that area is underneath the x-axis?
yeah.
So what does that tell you about that value?
It's negative.
It's negative. It has to be less than 0.
Right.
H prime of 6, however,
Like 6 itself. Yeah.
well, it's the derivative of h evaluated at 6.
hmm
And so what's the derivative of this stuff right here? Well, that stuff right there is an integral.
Uh-huh.
And so the derivative of an integral is just the function itself. So I guess if you really wanted to, you can first define h prime of x to be equal to just f of x.
Uh,
So now can you see that h prime of 6 would just be f of 6?
yeah.
And according to the graph, what is that?
0.
0. And then h double prime, if h prime is f, then h double prime of x must be equal to f prime of x. I'm just differentiating both sides.
Right.
So that's h double prime of 6 is like saying f prime of 6. And even though we don't know the exact number, do you remember how f prime tells us the slope of the tangent line at that point?
Yeah.
And can you see that that tangent line, even though we don't know what it is numerically, it's positive?
Yeah. So double prime's like the F prime's like the tangent line. Yeah.
Yeah. And so because it's positive, we know it's greater than 0.
Mhm.
So that's how we rank them. One's negative, one's 0, and one's positive.
Mhm.
So that's it. Yeah, so we go from least to greatest.
Bet.
Okay. This man Dev is trying to be great. I love it.
There.
Okay. Reverse power rule. Given the function f of x, find the antiderivative. So this is just something that we're trying to come up with, that when I take the derivative of it, in this case, I get x squared. And you know how the power rule says we bring down the exponent and minus 1?
Mhm.
So if we're working backwards, we're going to kind of plus 1 instead. But we can't just put x cubed.
Yeah.
Because if I took the derivative of that, it'd be 3x squared.
X
And we-
cubed over 3.
Yeah. Whatever we get when we add 1, we divide by that new exponent. So
Right.
that when I bring the exponent down, it cancels out with that bottom number.
Mhm.
But even if it was plus 5, I'm using 5 as a random number. It could have been any number. The derivative of any number is just 0.
Yeah.
So I could have put plus 7, or I could have put minus 84, whatever. So we're going to generalize it by saying plus c.
Mhm.
C being any constant.
Right.
Number 2, we can do term by term.
All right. So 5x cubed.
So we're
Oof.
going to keep the 5, but we're going to raise the third. We're going to make that to the 4th, and then go over 4.
Mhm.
So when you bring the 4 down from the exponent, it cancels out with the 4 on bottom.
Yeah.
And then the 5 stays there. So you got 5x cubed. Now, with this one right here, I would rather think of it as,
A negative exponent.
yeah. So when I add 1 to that negative 3, what's negative 3 plus 1? Negative 2
Negative 2. Yeah.
divided by that new negative exponent minus, I wrote this way too big, minus,
I should 0.
well, the derivative of 0
1x.
is just 0.
Yeah.
The
1x.
derivative of x is just 1 plus c. But we're going to simplify it. We'll say 5/4 x to the 4th minus 3x to the negative 2 minus x plus c.
All right.
Square root of x, we can just rewrite it as x to the 1/2.
Mhm. Plus 1. So that's 3 halves.
Over 3
Yeah.
over 2.
Yeah.
You'd have to keep change flip.
Wait, over 3 over 2 plus 1, right?
Well, you already plus the 1 to get 3 over 2.
Oh, yeah, you're right. You're right.
And then sine and cosine integrals, that's just a matter of thinking backwards. The
That's
derivative
like
of what would give me
negative
sine?
cosine x.
Plus c. Don't forget it.
And sine x plus c.
Thinking backwards. Fundamental theorem of calculus. If
F of
f
B minus F of A.
Yep, but because they're saying that capital F of x is the antiderivative, it's going to be
Mm-hmm.
capital F of B minus capital F of A.
Alright, so like, what would be
Had
the
it
like,
had it
what would
been
be
the
like,
hmm?
what would be like the main difference between capital and lowercase, Mr. Altman?
Capital F is this sentence right here. This is basically defining what capital F is.
That's the antiderivative,
Yeah. So when
and
you
the F
take
of X is the function itself.
right, that's why when they were saying before in the other fundamental theorem of calculus, they were saying if you took the derivative of this,
Mhm.
the derivative and the integral would cancel out, so that'd just be this.
Uh,
So without the derivative, it's capital F.
uh,
That is hard to explain
mm,
because they're using the same letter.
right.
Okay. Number 4 through 6, that's literally what our next assessment is going to be over. Evaluating definite integrals.
Like our next unit.
No, our next like section within unit 6.
Oh,
Yeah.
wait, we're gonna start this tomorrow.
Yeah.
Oh, we're trying to do one.
Yeah. Okay.
All right, definite integral. Wait, so we gotta do all of this backward?
Yep. What's something that when I take the derivative of it, I get 4.
4x.
4x. Minus, can we use that reverse power rule with the 6x?
3x squared.
Mm-hmm.
Yeah. It's minus 3x squared.
Now we got to evaluate, because that right there, that whole 4x minus 3x squared,
Yeah.
that is our like capital F of x.
Mm-hmm. And now we got the F of B minus F of A.
Exactly. So that bar with the 5 and the negative 2, that's notationally how we write what we're about to do. So that'll be, I like to use parentheses, so it'll be 4. I'm going to write it out fully too, so you can see exactly what I'm doing. Actually, I'm going to use brackets right here. Hopefully nobody said anything in the group chat like asking where to find it or something.
Yeah.
Dang, nobody replied. They don't want it.
They just want a day off.
They want a day off. We don't take breaks around here. We do that when I'm dead. All right, so I did 4x minus 3x squared evaluated at 5. Now I'm going to do the same thing evaluated at negative 2. They really don't give us enough writing space, bro.
Bro.
I just got my hair twisted up. This do-rag is tight.
Dang.
It sucks, though, because I don't get my hair cut until Thursday. So I got to rock
Wait.
a fresh retwist, but...
Well, where you go?
Do you know Mr. Cawley?
Yeah.
Yeah, I go to his sister.
Oh.
Yeah. Dang, this thing is on tight. All right, the rest of this is just arithmetic. 20 minus what? 75. 3 times 5 squared. What's 5 squared? 25.
Yeah.
3 times 25 is 75. All right, hold up. So this is 20 minus 75
plus
minus.
plus 8.
Hold on, let me do this first. So minus negative 8. So that's minus 12. 3 times 4. I don't know what 20 minus 75 is. I'm sure I could figure it out.
That's negative 55.
Yeah. If I wasn't lazy, I could have figured that out. Minus negative 20.
That's negative
What?
55
Negative
plus
35.
plus 20.
I don't know. Photo math?
Looks right. Looks right.
It does. Let's see. Can photo math solve definite integrals? Let's find out. I'm just going to get rid of this so it doesn't show up in the calculation. Photo math says negative 35. Okay. So that's how that's going to go. That's what oh, by the way, this next assessment, it's a straight no multiple choice.
Oh,
No multiple choice on this one, guys.
it's gonna be easy though.
It's gonna be like it's like the one we just did.
Oh, I could do that. I could do that.
It's gonna be some trig in there too though. And it's gonna be either some square roots or some funky fractions. Not funky fractions like 1 over x cubed type stuff.
I'm not gonna lie. I used to love trig until I took pre-calc. Made me hate trig.
That's when trig starts.
Nah, trig start geometry.
Oh, I mean that's basic trig. That's not real trig. That's just
Yeah.
right triangle trig. That's baby
Yeah.
trig.
That was really fun. It was easy.
Yeah, that's fake trig. It depends on if you know your trig or not.
I had to memorize the unit circle.
Yeah.
I had to do that in like 2 hours too, cause like I had to memorize it till second period. Like the whole thing. I did it in like one day.
Yeah, it's
Just
tough.
remember. Yeah.
How long have we been streaming for?
I don't even know. And Mr. Alvin, there's this one question too. So this is like f
Mhm.
prime of x is equal to 3x squared, and like f of 2 is equal to 3, and f of 1 is equal to like question mark.
Yeah, that one was hard.
How'd you do that?
Let me find it. I don't remember where it was. Actually, I know where to find it because I remember Will did it in class. Haha, I love my brain. All right, so look, we'll just add a page. Okay, so the question went as follows. It says if f prime of x equals 3x squared, right?
Mhm.
And f of 2 equals 3, then f of 1 equals what? Now, I read that f of 2 and f of 1, and can we see how automatically we can just look at this as like a f of b minus f of a? Hopefully that sticks out. That is the hope.
Wait, I think they just came up with a solution for it.
Okay.
Wait, hold up. Alright, hear me out. So,
Let him cook.
alright, so it's f prime of x, right?
Mm-hmm.
So all I did was integrate f prime of x. That's like x
From what
cubed.
to what?
3x squared. I just integrated 3x squared.
Yes, from what bounds to what bound though?
So 1 to 2, 1 to 2,
Yes.
and then basically that's like x cubed, right?
Mm-hmm.
But then we also have a constant, right? There's a possibility of a constant.
Yeah.
So like if f of x is equal to x cubed and then f of 2 is equal to 3, I just plugged in 2 to like x cubed and I got 8, right?
Mm-hmm.
So the equation gotta be x cubed minus 5, right?
Mm-hmm.
And then you plug in f of 1 in there, so it's like 1 minus 5, it's like negative 4.
That's one way to do it. That's how some people said it was easier.
Now
You see why we gotta have that plus c. That minus
Yeah.
5 was the c.
Yeah.
Mm-hmm.
Well, how would you do it, Mr. Alvin?
I didn't even think about it like that when I saw this question for the first time. So
Really?
that's what I was talking about when I was like, that's That's like the best part about math. Like you can get the same answer in different ways, which is dope. What other subject you know can do that?
Answer in different ways?
Yeah. Like you can't do
Nothing.
that in like what social studies class are you in? Like world history or something like that?
Yeah, what
I mean, I
history?
guess you could, but whatever.
Nah,
I'm
you
getting
can't.
distracted. I'm getting distracted.
Yeah.
But yeah, that's what I'm saying. Okay, so how I did it was the same way. I look at it as f of 2 minus f of 1.
Mhm.
And then look, before I put the 3x squared, I was like, if I do this, the integral of f prime is just the function itself. And because you have bounds, from 1 to 2, we can put this stuff according to fundamental theorem of calculus.
Right.
And then we said that since f prime was 3x squared, the integral was x cubed. You see this little bar notation
Yeah.
from 1 to 3? Oh, I put 3
Oh.
where I was supposed to put 2. But that still equals f of 3 minus f of 1.
Mhm.
And so the left side of the equation, you see how that's
F
just,
of 3?
huh?
Isn't it F of 2?
Yeah, you're right. I'm tripping. Yes. It's f of 2 equals 3. That's what I meant to put.
Yeah.
But the left side, do you see how it's 2 cubed minus 1 cubed?
Mhm.
What is 2 cubed? 8
8.
minus 1, 7.
Mhm.
7 equals 3 minus f of 1. Well,
Yeah.
3 minus what would give me 7? 3 minus
4.
negative 4.
Yeah.
3 minus negative 4. Because you know how minus and negative is like plus.
Right.
So that's how I got negative 4.
That makes sense too.
Mm-hmm. Man, multiple ways, multiple solution pathways. And they're both correct.
Yeah.
They're both correct. So that was that one. All right. So what are some more problems like this?
Wait.
Oh,
you hear how
look,
many
that's
questions-
crazy, bro. Look at number 7 on here. That's the exact type of question that we just did. That's crazy. That's kind of like psychic almost.
For real.
So this is just finding definite integrals. That's what we're doing. Okay.
Wait, you already made the retest, Mr. Allman?
Nope. I got to do that. I should probably do that like today.
You know how many questions it's gonna be?
I want to say like 6 per.
Like it's gonna be like two different retests, yeah?
Like versions?
Yeah, not like it's like categories, like for Riemann sums and stuff like that.
Yeah, Riemann sums and FTC.
Alright.
This website is clutch. One of my tutor clients put me on. Flipped math.
Mhm.
Bro, they got all the units.
Wait, is
all
it
the
free?
sections. Yeah. It's all videos and stuff. Like the video we were
Oh.
watching.
Yeah.
Hello, calculus.
They got worksheets too.
Why should you use
got
Miro?
worksheets.
When you draw on a
Yeah, it's-
whiteboard,
it's the
no one
plug,
sees
low
it.
key.
With Miro, you
Oh,
plug together
damn.
in real
I know.
Calculus, kids, this is Gene, and in
That's what I'm
today's lesson, we're
saying.
going to talk about summation.
I'll put the link in the chat.
Okay, yeah.
Bro, I want this Discord to blow up so bad.
Uh-huh. It should be, like, I don't know why it's not.
That's what I'm saying. I gotta tell more people about it.
For real.
Notation with respect to Riemann sums. And how you
Flipped
can-
math.
Wait, what's the difference between version 1 and version 2?
They're laid out differently. Like
Oh,
version 2 is like split up by semester or something. I don't know. It's like the
yo,
same
they
thing.
got everything out here.
That's what I'm saying.
Interval starts, and that thing is approaching this clean way of writing this in
I'm
calculus.
gonna bookmark this.
B
In
minus
case I forget.
one of these, or right, that is your x. I will over x. When first 0 and 10, part of the inner series and sequences, when we take the summation of them, how do they represent a definite interval? 'Cause this is the area under the curve of the cosine graph.
You know what type of questions you gonna put on the test, Mr. Lemon?
This is Mr. When we get to an ending,
Approximating areas with Riemann sums.
but it's still a healthy thing to know how to
Same type as the original test.
under the curve. The intervals are the basis of the whole.
Like for FTC, is it gonna be like a lot of word problems or just like mix of everything?
I mean, it could be anything FTC related.
Anything? Yeah. I think I feel like I'm all ready now.
Okay, good. Mission accomplished.
Yeah, I didn't even know you gotta multiply times like the chain before F time of like I just didn't
Hey,
know
now
that.
you know. Now you know.
Yeah,
Now you know.
I missed
Left
too
Riemann
much class
sum,
recently.
right? Oh yeah, you were gone. I forgot.
Yeah, I got a lot this month. It's over now though.
Plus, and I already factored out the 2, so I have
Facts.
f of 4.
You remember
Four is
Riemann
going to give me
sums?
8
A little bit. It's like
plus
rectangle.
6 is going to give
Yeah.
me
Like
a 6.
left Riemann sums
So
like
it is 2
that's like you start from the
times
left, so that's like
6 plus 6 is 12
underestimation.
plus 8.
Well, it depends on if the function is
So this is
increasing or
going to be
decreasing.
If it's like increasing, that's an
40 is my
underestimation, right?
For my left
I
Riemann
never
sum.
memorized it, bro. I
Now
always
you're
got to
gonna do
draw it
exactly
out.
the same
I'm not
thing.
gonna lie to you.
Yeah.
We're going from 2 to 8.
Like
so
we can
we're
look
going
at
from
this
2 to
right
8.
here though.
Alright, bet.
Like if you look at these rectangles, you see how the top left of each rectangle touches the graph?
Yeah.
That's how you know it's a left Riemann sum. And so it looks like for the first half of that parabola,
Mhm.
my function is increasing, and it does look like an underestimation because there's like gaps in it that are underneath the curve. But if you look at the right half of the parabola where it starts decreasing,
It's like over.
it's a over approximation.
I forgot how to do these, to be
There are
honest.
3
It's
subintervals.
just
Yeah,
length
the
times.
This is
It's just
one.
base times
So
height.
the width of
Not
these
even
two.
gonna
It
lie
is?
to you.
But in this case,
You're
Wait,
just
what are you gonna
adding
do
up.
with the
right Riemann.
extra area though?
I mean, it's an approximation, so
Oh.
it's not gonna be an exact area.
Oh.
Yeah. Find the approximation of the area under the curve.
So what I'd like you to do is just try exactly what we just did on our.
You know how many more grades we got this
left Riemann
quarter?
sum, but now think it's the right side of.
One for integrals. You know what I might do to make more grades? This next assessment, it's gonna be. So we're gonna do a practice tomorrow. It's actually already up.
Like for the next assessment?
Yeah, it's actually already up. I put it on quizzes.
Passport? Oh.
So look, can you still see my screen?
Yeah.
Yeah, both of these two are for y'all.
Uh-huh.
And that's what your assessment is going to be over. So it's going to be 2 more grades before IPR. Actually, no, because y'all will. Well, it just depends, honestly, because if we practice tomorrow, ideally, I would like to assess on Thursday so that I can get it in before IPR.
So this one's basically like if you know it, like it's a free grade.
I mean, it's just like the definite integrals that we were doing.
Oh.
And like properties of definite integrals, which are quite easy.
Yeah.
It shouldn't take more than a day. Plus, y'all need to be practicing at home anyway. So I feel like in-class practice plus your own practice should be sufficient.
Yeah.
It just sucks because A-Day will have had one more day of practice.
Yeah.
But I mean, shoot, it is what. That's just the woes of having block scheduling sometimes.
Bro. Wait, so you remember the semicircle divided into two in the triangle question, right?
Mm-hmm.
Like, was the answer for that like pi plus 1?
I think so, yeah.
You just like it's like 2 like pi like over 4 and then the area of the triangle, right?
Honestly, I don't remember. I'm gonna have to pull it up. Uh, number 8.
Uh,
Yeah.
I had a number 3, yeah.
Okay. So if g of 0 equals 1, what is
Hmm.
g of 3? All right. Well, our two x values that they give us are 0 and 3,
Yeah.
and we got to utilize the fact that they gave us the graph of g prime.
Hmm.
So if they're talking about g of 0 and g of 3,
Yeah.
how do we get from g prime to g? We got to
Integrated.
take the integral, which is the area under the curve,
Yeah.
from 0 to 3 in this case.
Hmm.
So here's how I would do it. I would just write it out as the integral from 0 to 3 of g prime
Hmm.
the integral from 0 to 3 of g prime of x dx, I think.
Hmm.
And that would be equal to, actually, can you tell me, using the f of b minus f of a stuff,
Yeah.
what would go on the right side?
So it'd be G of 3 minus G of 0.
Mm-hmm. So we know two of those three components. Like, they tell us what g of 0 is 1,
Yeah.
and we need to find g of 3.
Yeah.
And then we can also look at the graph to tell us the area from 0 to 3 of that
Right.
curve. So from 0 to 2, and then from 2 to 3.
That gives us G of 3, right?
Um, no, that gives us the integral from 0 to 3. That gives us the
Uh,
left side of this equation right here.
uh,
So the integral from 0 to 3 of g prime, it's a
Mhm.
quarter of a circle that has a radius of 2.
right.
So a circle with a radius of 2.
So that's just pi 2 square over 4. Like
Mm-hmm.
pi
Mm-hmm.
plus
Plus half of that triangle, because it's only from 2 to 3.
3.
So yeah, half of the base times the height,
Mm-hmm.
and then that base would only be from 2 to 3,
Yeah.
and then times 2. So 1/2 of 1 times 2.
1/2 of 1 side. So 1.
Okay, and then that again is what equaled g of 3 minus 1.
Alright. So
So
why would we like take the FTC for this one? Why won't we just like calculate the area from 0 to 3?
um I just thought of it because they asked us for g of 3.
Right.
So I guess maybe you could have, because like the area from 0 to 3 is this,
Yeah.
and that's not what they asked for. They only asked for this part right here.
Uh.
Yeah.
Oh. Alright. That makes sense.
Okay.
And like,
Algebraically, huh?
what you saying or something?
I was just saying, to get g of 3,
Mhm.
we just got to add 1 to both sides.
Yeah. So it'll be like pi plus 2.
Mm-hmm.
And what about the point slope, the tangent line equation?
Number 3.
Yes.
Okay, so in general, we had to know that the equation of a line is y minus y1 equals m times x minus x1.
Yeah.
And x1 and y1 are just points on the function, or a point on the function. And then m is the slope of that line. Remember, this is the equation of a tangent line.
Right.
And so they give us the x value. I don't know which version you got, but on this version, you see where it says at the point where x is -2?
I got x equals 3.
Okay. Well, we'll do x minus 3 then.
All right.
And
Yeah.
depending on what your function was, you have to plug in 3 in order to get your y.
Because it's like f prime of x. The equation for tangent line is like f prime of x, right?
Yeah, that's how you get your
That-
slope.
Oh,
It's
that
not
just
the
cancels
equation
out.
of the line, it's the equation that gives you the slope.
Right.
So
you
f
just plug
prime
in
of 3 is how you get your slope.
Uh,
But I don't know. What was your f of x?
my f of x was cosine pi t squared over 9.
Okay. So to get y1,
Uh-huh.
do you see how we just plug in 3 for x?
Yes.
So that's like finding f of 3. So
Wait,
wherever
for what I got 4 plus something. Wouldn't y1 just be 4?
well, that's what I'm trying to figure out. So f of 3, that is my y1. That's my y whenever x is 3.
F of 3?
Yeah.
Mm,
So in my function, wherever I see a t, I'm going to put a 3 instead. And so that just comes out to the 3 squared becomes a 9, which cancels out with a 9 on bottom. So we're just left with cosine of pi,
yeah.
which according to the unit circle is -1.
Mm-hmm.
So that's our m. I'm sorry, that's our y1.
So
it's
y1 is plus 1.
yeah. Well, the
I thought
y1 is -1. The
I
y
thought it
value
was 4.
oh, it was a 4 plus. It was a something
Yeah.
before your cosine, wasn't it?
Yeah.
That's what it was. What was it?
4 plus. Yeah.
Okay.
So we just found the slope, right?
No, we just found the y value whenever x was 3.
So how we find the slope?
You got to take the derivative. Remember, f prime gives you your slope.
Oh, so that's just like wait, so derivative cancels out the integral, so it's just plugging in 3, right?
I think you gave me the wrong function when you said cosine of something. Wasn't
Yeah.
there more to it?
No, it just says integral of 3 to x cosine.
Yeah, the integral part. Then we need
Yeah.
that part.
Uh,
It was 4 plus.
yeah, 4 plus integral 3 to cosine x. I mean 3 to x.
Okay. So wait. Okay. Okay. And was that f of x or f of t? That was f of x. Okay, so that makes sense as to why it was 4. We didn't have the 4 plus at first.
Yeah. The m would just be -1, right?
Let's see. So if I take the derivative of f of x, the derivative of 4 is just 0, plus the derivative of an integral is just the cosine function itself. And we're going to replace a t with an x. So that right there is our f prime of x, but we're trying to evaluate it when x is what, 3?
Yeah.
So this is cosine of pi, which is -1. That's our m.
Yeah.
So that is your equation of a line.
Mhm.
Yes, sir.
Wait, so you know let g be the function given by g of x, the x-coordinate of the point of inflection, right?
Mm-hmm.
That's just a double derivative, and then you equate that to 0, right?
Mm-hmm.
Alright. I'm ready for this.
This man said, throw it at me. I'm ready.
Yes,
That's what's
sir.
up. That's what's up. What else are you about to do today?
Dude, I don't really got nothing.
Chilling.
Yeah. You play any games, Mr. Altman?
Nah, I think I want to do that question that we did from 0 to B. Where was it
The
at?
the the graph?
Yeah, this one right here.
Yeah,
I want to do this. I want to make a TikTok
I
doing this
bet.
problem. That one was kind of weird.
It was just the wording, like
Yeah.
the work was like really simple, but the wording just gets you.
Yeah. I want to know like how other people would solve this cuz I don't know like if I'm doing it the right way or what. But I'm going to
Yeah.
make a video on this one.
hmm
Or I don't know. I might do some other calc problem. That's what I'm gonna do. I'm gonna make a TikTok before I go lift. I gotta go
Oh,
cook though.
right. You work out twice a day?
Nah, I went. I'm going today with. Oh, you don't know him. He's a senior,
Uh,
but we're gonna do chest and tries. We might make a TikTok out of that too.
chest and tries.
Mm-hmm.
I did that 2 days ago. Actually,
Nice.
I do chest and back.
Yeah, I heard of that before.
Yeah. I go shoulders, tries, and buys.
Nice. Boys been getting at it. That's what I like to see.
There. I couldn't work out during swim season because if I got injured, that would just been
Oh yeah, true. We don't want to do that.
yeah.
All right, bet. Well, tomorrow I see y'all tomorrow. Yes, tomorrow's a B day. Thank goodness.
Yeah.
So we're just gonna do some. Though basically, all we're gonna do is those two quizzes assignments:
Mhm.
definite
Hey,
integrals and properties of definite integrals.
when do you think you're gonna get the retest done? I mean, like made.
Probably like that's a good question. Cause y'all are gonna have to come in to do it.
Like before school advisory, yeah.
Yeah, and I'm gonna have to shut down advisory.
Uh,
So I guess I'm gonna have to have it done by tomorrow.
mm,
But it shouldn't take long. It'll probably be on paper,
mhm.
and I think 6 questions is a good amount for you to
A
either like.
multiple choice, like or mix of both.
Actually, no. It can't be 6 because the original. Wait, actually, I feel like either way, you still gotta solve your answer. You know what I mean?
Yeah.
So I feel like it doesn't really matter. So I think
Mhm.
5 questions each would be good.
Like,
And
like
I
all
feel
fill in the
like
blank.
if I do FRQ, then I'm more able to give partial. Because with
Yeah.
MCQ, it's just right or wrong.
Right.
So yeah, FRQ would actually probably work in your favor.
hmm
So yeah, we'll do that. I can just
So you
I can
you
just
gotta
cook
get it and
up
play Apex.
Apex.
Yeah.
Man, I'm trash.
You should
I'd
hop on
rather
with me sometime.
I have it downloaded, I think, but
Yeah.
I be on Call of Duty.
You gotta play